All right. The first 4 or 5 questions on CBE3 are all based on um, law of sines or cosines. So if we had a triangle and the angles were labeled A, B, C, then we would call the side opposite capital A, little a, and this would be little b, and this would be little c. And the formulas we're going to be using are the sine of angle A over side A is equal to the sine of angle B over little b and the sine of angle C over little c. And this is called the law of sines. And the law of sines works when you have angle, side, angle, or angle, angle, side, or angle, side, side. And the other one is called the law of cosines. And it looks a lot like the Pythagorean theorem. It's a squared plus b squared. And then over here we have equals c squared. But in the middle, we have minus 2ab cosine of c. And when you're dealing with right triangles, we always said that c has to be the hypotenuse. And so angle C would equal 90 degrees. And then right here, the cosine of 90 degrees is 0. So that essentially wipes this piece out. And we're left with a squared plus b squared equals c squared. So the Pythagorean theorem is a special case of the law of cosines where c is a right angle. But the law of cosines can actually be written using angle C or angle A or angle B. And the angle dictates which formula you use. So the angle A formula would equal a squared, and the angle B formula would equal b squared. And then we just have to fill in the 2 remaining letters. So this would be b squared plus c squared minus 2bc, or a squared plus c squared minus 2ac. So law of sines, law of cosines. The law of cosines works when you have side angle side or side side side, and it actually does work with angle side side, but in my experience, nobody likes to do it that way. So we're just going to stick angle side side with the law of sines. All right, I'm going to lock all of this stuff. Okay. So let's say we had 40, 50, and 10. And I wanted to know what is side B. So we'd use the law of sines, and the sine of 50 over B, so this over this, is equal to the sine of C over 10. Well, what is angle C? I'd have to figure that out. So 40 plus 50 is 90, which makes that 90, like that. Now we cross multiply. So 10 sine of 50 is equal to b sine of 90. So we divide by the sine of 90. And anyway, we just plug that in. 10 sine of 50 divided by the sine of 90, which ends up being 1. And we get 7.66. So this side here is 7.66. Now I could do the same thing to find A. If I did the sine of 40 over A is equal to the sine of 90 over B, then I could find angle A. So that's how you use the law of sines when you have an angle side angle. When I say angle side angle, I mean we have 2 angles and the side between them. All right. So let's do an angle side. So let's say 60, 70, and 5. Okay. So the sine of 60 over 5 is equal to the sine of 70. Oh, let's say I want to solve for b. Sine of 70 over b. So we cross multiply. b sine of 60 equals 5 sine of 70. Divide this by the sine of 60, and that will tell me side B. Okay, so that's not too bad. Let's do a side angle side. So let's do this one here. So I need a side, 10, and an angle, 56, and the side on the opposite end of that angle, let's say 12. Well, what angle am I using? I'm using angle A, which means I need to choose the A formula. So A squared is equal to 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of 56. And notice there are no variables in there, so I'm just going to plug them all in and then take the square root. So 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of 56. And raise that to the 1/2. So the answer is 4.5. So if we had another side angle side, so let's say that this is 7 and this is 110 and this is, say, 15, and we wanted to know angle A. Well, there's no direct way to get angle A. If you try to do the law of sines, you don't have enough angles. And if you try to do the law of cosines, you can figure out angle C, or side C, and then you can figure out angle A. So you have to start by saying C squared equals 7 squared plus 15 squared minus 7 times, minus 2 times 7 times 15 times the cosine of 110. And then you plug all that in your calculator. 7 squared plus 15 squared minus 2 times 7 times 15 times the cosine of 110. And then square root that. And we get 18.6. So C is 18.6. Now, we could say the sine of A over 15 is equal to the sine of 110 over 18.6, and then we would just times this by 15. So 15 sine of 110 over 18.6. And that is our ratio, so we need to invert the sign of 0.7578, and that will give us the angle of 49.3. So that's how the law of cosines works, and mostly how the law of sines works. So angle side side is the tricky one. This is the difficult one. So let's say that this was a 40-degree angle, and then little c was 10, and little a was 12. And this much of the triangle is set in stone. This line has a specific length, and then this angle here relies on 40 degrees. But I don't know how long B is. So I sort of have a hinge right here, and this can swing in either direction, that second side. So we always put the swing in the crack right there. And if the second side is larger than the first side, then when I have this swing, it really only hits side B in one place. So if I were to draw that whole circle all the way around, the only time that side A hits side B is going to be right there. And that's because 12 is bigger than 10. If 12 was shorter than 10, so let's say 12 is only this long, when it swings, it has the chance of hitting twice. But if that side is really short, it might not hit at all. So angle side side either has 2 triangles, or 1 triangle, or 0 triangles. It just depends on how long that third side is. So let me erase all that, and then we'll actually work this problem. So 40, 10, and 12. Whenever side 2 is larger than side 1, there is one triangle. That's it. And I want to find side or angle C. So the sine of 40 over 12 is equal to the sine of C over 10. Multiply both sides by 10. So 10 sine of 40 over 12 is equal to the sine of C. So 10 sine 40 over 12 is 0.53, and then we have to invert the sign, and we get 32.4. And you probably want to use more decimals than that. 32.3884. 3884. Okay? And now if I want to find this angle, that's easy. We just add those together and subtract from 180. And then once I know this angle, I can use the law of sines to figure out side B. That is when you have one triangle, when the second side is longer than the first. So let's do the same problem, but let's change this to like a 6. Okay? And I want to solve for angle C. So the sine of 40 over 6 is equal to the sine of C over 10. So we multiply by 10. We have 10 sine of 40 divided by 6, and I get that the sine of C equals 1.07. Well, sine is O over H. So that's like saying my O is 1.07 and my H is 1. If I try to draw that triangle, and O is 1.07 and H is 1, is there any way in a right triangle for the opposite side to be larger than the hypotenuse? No. So when I try to invert 1.07 using the sine function, I get an error. That triangle does not exist. What does that mean? Well, it just means that this side is so short that no matter where I swing it, it never hits side B. So there are no triangles in which that works. Okay, so let's do the same problem. 40, 10, and let's make this an 8. Okay, so the second side is shorter than the first side. So either we have 2 triangles or 0 triangles. Remember, when this side is really long and we swing, it only hits once. But if it's shorter, it could hit twice. If it's really short, it doesn't hit at all. So let's see if this is enough to hit twice. So, because this is smaller than that, these are my 2 options. 1 is not an option. So we have the sine of 40 over 10, or no, sine of 40 over C. Holy cow, I'm way off. Sorry. The sine of 40 over 8 is the sine of C over 10. So we times this by 10. 10 sine of 40 over 8. Wow, that was a bad idea. 10 sine of 40 over 8. And now I get a number less than 1, so I know that it exists. The sine of C equals 0.8. So if we invert that answer, I get 53.4641. So C is 56.4341. Okay, well, that's one of the triangles. But let's take this length and swing it until it hits a second time. And now angle C has moved to be over here. What is that angle? Well, this side is 8, and this is the same side, so it's also 8, meaning that's an isosceles triangle. So that angle must equal this angle. So over here we write 56.431. So now we have a new triangle that looks like this. That angle is still 40 from the original problem. This side is still 10, and this side is still 8. So that angle right there must be the supplement to 56.431. So we just take 180 and we subtract our angle. And this angle here is 126.54. Okay? And those are the two triangles. So they both have a 40, they both have a 10, they both have an 8, but that angle is 56.4, and in the other triangle, that angle is the supplement, which is 126.4. All right, now let's work a couple problems. So every time we draw the same triangle, A, B, C, A is 61.7, B is 47.7, and side C is 26 centimeters, and it wants to know angle C. So this is angle side angle, so we'll use the law of sines. So the sine of 61.7, oh, sorry, let's not do that. C is going to be 180 minus 61.7 minus 47.7. So 180 minus 61.7 minus 47.7. Angle C is 70.6. Okay. And now it wants us to find the length of side opposite A. So this one right here. So the sine of 61.7 over A is equal to sine of 70.6 over 26. And then we cross multiply A sine of 70.6 equals 26 times the sine of 61.7 divide by the sine of 70.6, and just plug that in your calculator. Make sure your calculator is in degrees, and that would be it. Use exact values to calculate the length of the side opposite B, and then type a 1 decimal approximate. So when it says exact values, it means don't round any of your decimals until you get to the very end. So to find side B, we would just do the sine of B over little b is equal to the sine of 70.6 over 26. And same thing, cross multiply, and then just solve for little b. Okay, that one's pretty easy. All right, new triangle. So A, B, and C. A is 41.8, and the exact length of the side opposite A is 12.8, and the exact length opposite C is 18.6. So this is an angle side side. And side 2 is smaller than side 1, which means we could have two intersections. So if this side is longer, it only has one answer. If that side is shorter, it either has two answers or no answers. So we set it up. The sine of 41.8 equals, or over 12.8 is equal to the sine of C over 18.6. So we multiply this side by 18.6. So 18.6 sine of 41.8 divided by 12.8. And if I got a number bigger than 1, the answer is no triangles. If I get a number smaller than 1, it means two triangles. So this one does have two triangles. Okay, so the sine of C is 0.968. And this is where you don't want to round. So don't round this. Okay, so we're going to invert. So sine inverse of the answer. I get 75.59. Again, don't round this. On and on and on. That is the measure of angle C. But there are two options for C. The other option would be this angle here. So this is 12.8 and this is 12.8. So if this is 75.59, then this is also 75.59, which means that is going to be 180 minus the answer. And again, don't round any of those decimals until the very end. So 104.4. Now, when you put these in, so it says, and this is really dumb, put the smaller one first and the larger one on the right. So I would write, and it wants a 1 decimal approximation. So 75.6 and 10, what was it? 104.4. So 104.4. Now if you mix those up, I'll mark it right for you. But what if there's only one answer? Then you put your first answer and then you put NA in the box next to it. What if there are no answers? Then you write NA in both boxes. Okay. 3. Same triangle. A, B, C. A is 68.7 and side A is 19.3 and side C is 16.6. This is larger than that, which means when I swing, I won't hit again. So we just write out the sine of 68.7 over 19.3 and the sine of C over 68.7, knowing that there's only one answer. So I times this by 68.7. So 68.7 times the sine. Oh, that's not right. This is 16.6. So 16.6 times the sine of 68.7 divided by 19.3. And I get 0.8. So I invert the sign and I get angle C is 53.2593. All right. And so I would put that number in there and then I would put NA here. All right. Same triangle. A, B, C. A is 92.4. The exact length opposite B is 33.3 and opposite C is 30. All right. And I want to know what is side A. So this is a side angle side, which means I have to use the law of cosines. And I know angle A, so this is going to be the A squared formula. So this would be 30 squared plus 33.3 squared minus 2 times 30 times 33.3 cosine of 92.4. Plug all that in. 30 squared plus 33.3 squared minus 2 times 30 times 33.3 times the cosine of 92.4. And then we have to square root that, so raise it to the 1/2, and I get 45.7. All right. So side A is 35.7, side B is 44.9, and side C is 14.2. And we want to know the measure of angle B. So we have to use the B formula. So 44.9 squared is 14.2 squared plus 35.7 squared minus 2 times 14.2 times 35.7 times the cosine of B. Now, we need to solve for all of this. So I'm going to move this over using subtraction. And I'm going to move this over using subtraction. And then you have to be careful because it looks like you can move this using addition. But we have to follow the order of operations, which says we need to chunk all of this together, and then it is held to the cosine using multiplication. So we need to figure out what that number is and then divide it. So we'll take 44.9 and square it, and subtract 14.2 and square it, and subtract 35.7 and square it. Okay. And again, don't round anything. So 539.88 is equal to, and now let's figure out what this is. Negative 2 times 14.2 times 35.7. So I get negative 1013.88, again, don't round it, cosine of B. So to figure out what B is, I need to divide this number by this number. And I get negative 0.532 equals the cosine of B. So we invert the cosine of the answer, and I get 122.2 degrees. So this is 122.2. All right. I'll save the future problems. Well, hold on, let me check. Yep, I'll save the future problems for a future video.